On March 23, 2012, a chilling message crackled over the radio at NASA Mission Control. The crew of the International Space Station, ISS, was alerted to an imminent threat, a swarm of micrometeorites hurtling towards their orbiting home. Panic gripped the astronauts as they realized there was no time to alter the station's course. But this raises the question, how does the ISS manage to evade these deadly space hazards in the vast, perilous expanse of its orbit? How does it steer a structure weighing as much as 380 cars without fuel and without Earth's immediate assistance? The ISS, constructed at an astronomical cost of $150 billion, or roughly 12.375 trillion rupees, is humanity's unprecedented abode in space. Its assembly required an array of cutting-edge technologies and high-tech parts. The ISS comprises 16 pressurized modules, each serving distinct purposes such as living quarters, sleeping areas, an observation deck, and 6 state-of-the-art science labs, all interconnected by airtight tunnels. Additionally, the station is equipped with spare docking areas for capsules and maintains lifeboats ready for emergency evacuations back to Earth. The International Space Station stands as the largest space station ever built. Spanning the size of a football field, it orbits 400 kilometers above our planet, visible through binoculars. To grasp its magnitude, the ISS is larger than the base of the Burj Khalifa. Weighing in at a staggering 400,000 kilograms, it equals the weight of 380 cars or 25 passenger buses. But how did such a colossal structure find its way into the boundless expanse of space? The ISS started with just 2 modules, one built by America and the other by Russia. After the breakup of the Soviet Union in 1992, the United States and Russia decided to collaborate in building the International Space Station in space. Russia initially sent a module named Zarya into space, followed by America launching its Unity module. On November 28, 1998, at 6:40 a.m., these 2 modules connected in space 400 kilometers above the Earth, giving birth to the International Space Station. Since then, over the past 26 years, engineers worldwide have collaborated to build their respective modules and connect them to the ISS using rockets. Today, in addition to the US and Russia, European and Japanese modules are also attached to the ISS. Not a single day has passed in the past 24 years when the islands has been empty. It always hosts astronauts from various countries. It is equipped with all the facilities necessary to support astronauts inside, the most crucial being oxygen. A person can survive without food for up to 3 weeks, without water for 3 days, and without oxygen for only 3 minutes. Above 400 kilometers from Earth, where there is no atmosphere or oxygen for breathing, the biggest challenge for the ISS is to provide fresh oxygen to astronauts. An average person needs 15,000 liters or 22 kegs of oxygen per day. Providing nearly 200 kegs of oxygen per day to the 9 astronauts living on the ISS is indeed a huge challenge. Many days of oxygen supplies are stored in tanks on the ISS to ensure astronauts can breathe until new supplies arrive from Earth, via rockets. Technology has advanced so much that oxygen can be delivered from Earth to the ISS in just 6 hours. But this method is costly because it costs $200 million for a cargo rocket to travel from Earth to the ISS, or 16.5 billion rupees. Food and other supplies are sent once every few months, but it is challenging to repeatedly use rockets to meet the daily 200 kegs of oxygen demand. Therefore, the ISS generates its own oxygen without depending on Earth. It has a small machine that uses water to produce oxygen. When electricity passes through water, it breaks into 2 parts, hydrogen and oxygen. Bubbles of hydrogen gas collect on the positive electrode, while bubbles of oxygen gas collect on the negative electrode. If this experiment were conducted on Earth, these bubbles would separate from the water because gas weighs less than water. Therefore, the machine spins to create centrifugal force, which acts as artificial gravity. The water moves to the sides and oxygen gas remains in the middle, which the machine collects and stores in a container. You may wonder where the water comes from in space to make oxygen in the ISS. Here too, excellent engineering is demonstrated. In this process, the hydrogen gas produced is reacted with the carbon dioxide gas expelled by astronauts to produce water again, And finally, methane gas is discarded in space. Making oxygen for the International Space Station is a huge challenge in itself, but an even greater challenge is maintaining that oxygen supply. Even a small leak in the ISS could lead to catastrophic consequences, potentially causing the station to explode in an instant. This risk is comparable to the recent destruction of the Titan submersible. In the ocean, pressure is high, but within the controlled environment of the submersible, a small leak allowed external pressure to cause it to implode in less than a second. Conversely, in space, the external pressure is zero, while the ISS maintains internal pressure. A small crack in the ISS could lead to decompression and explosion. The ISS orbits the Earth at a height where space debris is abundant, moving at very high speeds. This debris includes parts of satellites and hundreds of small and large meteoroids. The question arises, how does the ISS protect itself from these meteoroids? The ISS orbits the Earth at a speed of 27 kilometers per second. At such a high speed, if the ISS were to collide with even a grain-sized meteoroid, it would be akin to a car crashing into a tree at 80 kilometers per hour. On March 23, 2012, NASA's Mission Control radioed the ISS crew about some space debris heading straight towards the station. The crew was informed only 6 minutes prior, but fortunately, the debris passed by the ISS without causing any harm. However, the ISS cannot rely on luck every time. To protect against small particles, the ISS is constructed with bulletproof materials. Similar to a bulletproof vest with multiple layers, the ISS's outer shell consists of several layers. The outermost layer of aluminum, followed by a layer of a special material, and then another layer of aluminum. No single metal is as strong as multiple layers of the same metal. Tiny micrometeoroids constantly strike the ISS, but its bulletproof layers have protected it for the past 26 years. However, if a larger meteoroid were to collide with the ISS, the bulletproofing might not be sufficient. Mission Control on Earth constantly monitors the positions and locations of incoming meteoroids. If a potential threat is detected, the entire ISS can be moved out of the way using small thrusters that run on rocket fuel, which is reserved for emergencies. To reduce dependency on Earth, the ISS has a mechanism to change its direction without using rocket fuel. Small boxes called control moment gyroscopes, CMGs, are installed in the center of the ISS. These CMGs contain flywheels that spin at a speed of 66 rounds per minute. When spun at high speeds, these flywheels generate angular momentum, which is transferred to the entire body of the ISS, causing it to move in a particular direction. The faster the flywheels spin, the more the direction of the ISS changes. If the ISS needs to be turned in the opposite direction, the flywheels are spun in the opposite direction. These flywheels are powered by electricity generated by the ISS's solar panels. Let me tell you about the fascinating secrets of the International Space Station, ISS. One of the most critical aspects of the ISS is its solar panels. These panels aren't fixed, they move to follow the sun. The ISS orbits Earth so rapidly that it experiences 16 sunrises in a single day. Because of this rapid movement, the sun's position changes quickly. If the solar panels were stationary, they wouldn't get direct sunlight, and their efficiency would plummet. Instead, these panels constantly adjust to face the sun, generating up to 120 kilowatts of electricity at a time. That's enough to power 110 air conditioners on Earth. Communication with astronauts aboard the ISS used to be a significant challenge for Mission Control. Radio signals, which are used for communication, can't penetrate the Earth, and often the ISS is on the opposite side. Initially, airplanes were employed to catch these signals and relay them to Mission Control. However, this method was both costly and unreliable, frequently causing communication blackouts for up to an hour. These blackouts would last until the ISS orbited back into range. Fortunately, advancements in technology have resolved this issue permanently. Now, high Earth orbiting satellites handle communication. When the ISS needs to contact Mission Control, signals are captured by these satellites, relayed through a network, and finally transmitted to Mission Control. This process ensures continuous communication with only a few seconds delay, allowing astronauts to easily stay in touch with their families. For the past 26 years, scientists around the globe have been working tirelessly to make the ISS self-sufficient, aiming to minimize its dependence on Earth. While many breakthroughs have been achieved, some requirements still necessitate Earth's support. These include food supplies, chemicals for water filtration, spare parts, and crew transfers, as astronauts can't stay in space for more than 8 months. The ISS is equipped with various laboratories for conducting experiments, many of which focus on the human body. The goal is to understand the challenges humans might face when traveling to Mars or deep space. The ISS is a mere 6 hours away from Earth, but a journey to Mars would be vastly different, lacking immediate support from Earth and making a return trip much more difficult.